Alright guys, today's goal is to understand graphs of functions, okay? So just plug the negative one in and calculate. So you'd get -5, -2, 1. Graph those 3 points, okay? So you go -1, -5, 0, -2, 1, 1. And they should line up. Now, anytime we're graphing, remember to fill the graph. Don't draw a short one, okay? So let's take a look at another. Alright, so you'd get 0, 3, 6. So -3, 0, 0, 3, 3, 6. So hopefully we remember how to do these, and these are pretty easy. Let's take a look at some more. Alright, here's some non-linear, but it's still pretty much the same. Look. F of -1 equals -1 squared plus 1. Just remember, anything squared is positive, so 1 plus 1 is 2. So here you get 2, 1, 2. So you have -1, 2, 0, 1, 1, 2. And remember, quadratics are parabolas that open up or down. Okay? If you need reminding, I'll show you how to graph those in your calculator. Just ask me in class. Let's take a look at another example. Alright, piecewise. What I mean by that is this piece is only for when x is less than 0. This is when x is equal to 0, and this is when x is greater than 0. Okay? So if I plug in -3, that applies to the top piece. So I would get 0, 1, 2. Okay? And then here I would get, well, when it's greater than 0, that applies to the bottom piece. Okay, so now I'd have 4, 3, 2. Now, don't forget, when it's saying to graph, it wants to graph the whole thing. So we already have this point. It's 0, 0. This is the y value, that's the x value. Okay, so we can graph the point 0, 0. And then -3, 0. -2, -1. And, -2, positive 1. And -1, positive 2. Now what you do is you still have to plug in 0 for this top one here, and you'll see what I mean. So if I plug in 0, you get 3. So if I go to 0, 3, you put an open circle. Okay? So hold on, let's redo this so we understand this better. What you need to do is put an open point right there. Okay? And then we come down to here. Okay? So now we got a graph. 1, 4. 2, 3. 3, 2. But you also need the 0 for this one. So if I plug that in here, it'd be -0 plus 5 is 5. So I also have to go to 0, 5 and do another open circle. Okay, there's the piecewise function. Okay, so let's take a look at some more examples of graphing. Alright, well here's another piecewise. So again, -3 belongs to the top row. So you'd go 2 times -3 is -6, plus 3 is 3. -4 plus 3, -1, that should be -3. And then 2 times -1 plus 3 is 2. Okay, so again what I did was 2 times negative 3 plus 3, negative 3. Okay? But don't forget, we still need to worry about the 0 there. So if we did, we'd have the point 0, 3. Okay? Now, let's take a look at the next table. Plug in the 0, you get 3. Plug in 1, you get 2. Plug in 2, you get 1. Okay, so now we have all these points we have to graph. So I have negative 3, negative 3. Negative 2, negative 1. Negative 1, positive 2. And then remember 0. Oh. Positive 1. And then remember 0 and 3, open circle. Okay? And then the other one, now 0, 3. See how it is a point? So that's why you fill it in. And then 1, 2, 2, 1. Okay. Let's take a look at another example. Okay. Now this is where you need to open up your notes packet there again and then look at some things. What we're going to be dealing with here is this. F, or a better way to remind you of is previous year as well. We have f of x equals a times the quantity x minus h squared plus k. And remember, a is a horizontal stretch or shrink. Also, if it's negative, it means reflected. H moves left or right, K moves up or down. So it says identify the type of transformation and then graph. Just get out your calculator and look at the graphs for these. Don't worry about the graph piece. So it said x squared plus 2. Well, that 2 is the K. So what does that mean? Up 2. Down 4. This one means left 2. Because see how this says minus? That means you had to plug a negative in to get it. Right 4. This means right 3, up 1. This is reflected over the x axis, and that's because of the negative, and up 4. Okay? Hopefully you remember these things. Let's take a look at some things. So here will be a good example of what we mean by these shifts up here, okay? So if I look, this means it's going to be right 1 unit, okay? Now, so here's the problem with that. Well, let's start. If we start with just the parent function, which would be f of x equals x squared, you would have negative 1, 0, and 1. Okay? So f of x equals x squared. If we plug those in, you get 1, 0, 1. So if we go to graph that one, we have that. Now, see how it says we're saying that we moved right 1 unit? Well, right 1 means add 1, add 1, add 1. Doesn't change the vertical, it means move right. So our new graph is going to be 0, 1, 2. But these values stay the same. Okay? So if I go to graph those now, I have 0, 1, 1, 0, 2, 1. See how all it did was move it right 1 unit? Okay, so let's look at the other questions that are on there. It says, how has this graph changed compared to the parent function? It was moved right 1 unit. Okay? We've talked and spoken that. So it says, given the function g of x equals negative square root x, graph the function. Okay, so the negative means reflected over the x-axis. But before we get in that, I want to look down here. How is the graph changed? Reflected over the x-axis. Now domain. Domain is this, 0 to infinity. Because if you plug this into your calculator, it's going to tell you error because you can't do the square root of a negative. Now the range, well, this is where what we need to do is plug some things in and figure it out. So start with 0, you get 0. If I did 1, well, I'd have negative square root 1, which is negative 1. If I did 4, why am I doing 4? Because it's the next perfect square. You get negative 2. So the range is going to be negative infinity with a maximum of 0. Because see how this is decreasing the whole time? Okay. Well, now we have those 3 points to be able to graph. We have 0, 0, 1, negative 1, 4, negative 2. And it's going to look like this, and check your calculator to help. Now the parent function would look like this. It'd still be 0, 0, but then these would be flipped up here, which is why it's a reflection over the x-axis. Okay? Let's take a look. Alright, we'll see you guys in class. If you have questions, ask.